Hello students, today we will discuss more about canonical transformation and generating function. So in this session, we will find out what is the significance of generating function, that is how it will be generating the transformation equations. So as we have mentioned, a generating function is a part of the condition for getting any transformation to be canonical, where we have seen f as the generating function, which acts as a bridge between the old set of representation and the new set of representation, capital Q, capital P. So whenever we choose f, there are four ways of choosing a function f, and it would be a second order of that function would also be a continuous one, because the first order of the function is involved, and hence if the first order function is there to exist, it must have a continuous second order derivative. That is a mathematical aspect of the function. And looking at the dependency of the function as such, it is a practice that we choose the function, half of the dependency will be on the old coordinate and half will be on the new coordinate or new momentum along with time. So there are four ways of choosing such a generating function. One is we can have f is equal to a function f1, which is a function of small q, that is all representation, and capital Q, which is the new representation, and time t. And another way of choosing the function is keeping the all coordinate as q and new dependence as capital P and time t. And the third way of choosing is a function is f3 could be a function of old momentum, new coordinate, and time t. And lastly, the fourth option available is f4 can be chosen as a function of all momentum, new momentum, and time t. And it is easier to remember also, because you can see we are keeping q constant first and varying capital Q and capital P to get f2, and in order to get f3 we are changing the second available option in all system, that is momentum and capital Q, then momentum and capital P. So these are the four generating functions available, considering the concept that the half the dependence must be from the old set and the other half must be from the new set apart from the dependence on time. So let us see what does this generating function as such specify. It can specify equations of transformation. Let us see how it generates the transformation equation as such. That is, if you substitute for f as f1, you know f1 is a function of three parameters, q, capital Q, and time t. So if you take the total derivative of a function which is dependent upon other variables which can have a variation with respect to time t, then we can write this df1 by dt as a partial derivative of f1 with respect to one of the dependent variable, that is qi, into dqi by dt. Okay, plus, and what is the other dependence of f? F is dependent also on capital Q. So it is dou f1 by dou qi, partial dependence, into the q is solely dependent on time also. So dqi by dt, plus the last dependence of f1 is on time. So it is dou f1 by dou t into dt by dt, which is 1. Okay. So whenever we write the total derivative of a function, we choose to write in this form, where first we vary the function with respect to the dependent variable, that is qi or capital Qi or time t, into the corresponding total derivative of the variable. Okay, so here the corresponding variable is dqi by dt. Okay, now instead of writing dqi by dt, we can write it as qi dot d capital Qi by dt, we can write Qi dot, capital Qi dot plus dou F1 by dou t. So here you can see there are terms involving Qi dots, capital Qi dots, Hamiltonian, new Hamiltonian, as well as the time derivative. Okay, so you can see that all these Q or capital Q, if you take as such, they are generalized coordinates which are independent of each other. Okay, so the old Qi and the new capital Qi, which are present as variables in the function f1, are separately independent, and hence in order for the equation to hold, the coefficient of Qi dot as well as capital Qi dot must be separately vanishing. Okay, so in that case, if you consider Pi, it would be the coefficient of Qi dot. Here you can see, considering Pi Qi dot, and the other one is here Qi dot is present. So those are the two terms available. So we can equate those two coefficients. So what you get, Pi is equal to dou F1 by dou Qi. Similarly, equating the the coefficient of Qi dot and capital Qi dot, we'll get it as minus Pi equals dou F1 by dou Qi. Okay, and the remaining terms can be clubbed up, so it is equal to minus h equals minus f plus dou F1 by dou t. So finally what you get is k is equal to h plus dou F1 by dou t. Okay, okay, so the generating function, the transformation equations of f1 can be rewritten, can be consolidated as Pi is equal to dou F1 by dou Qi minus Pi equals dou F1 by dou Qi, k of Qpt, or k is equal to h plus dou F1 by dou t. So here it is easier to remember also, because f1 is dependent upon q. So the transformation equation would be in terms of Pi. Q is already there, so we need to find out Pi. How do you get Pi? You just have to vary the function with respect to the canonical coordinate. The canonical coordinate is Qi. Okay. Similarly here, capital Q is already present, so we need to find out P. P is equal to dou F1 by dou Qi. Okay. And a negative sign is also there. And K is equal to h plus dou F1 by dou t. That would be the same for all the generating function. And the next confusing thing is, we have learned the transformation equation as Qi is equal to a function of small q, small p and time t, and capital Pi equal to Pi, a function of small q, small p and time t. So how can you relate, or how do you expect these two equations to be like a transformation equation? So what do you do about that? So here you can see that f1 is a function of, I can write here as f1 is a function of q, capital Q and time t. Okay, so if I do this differential, and that then it would be a function of say f will get a function dependent upon small q, capital Q and time t. Okay, I can just rearrange the equation. That is what you meant by inverting the equation. So by inverting the equation, I can see that Pi can be inverted. So I can write it as Qi is equal to Qi, a function of small q, small p and time t. Okay. Similarly, so that is how the Pi is equal to dou F1 by dou Qi is a function of can be considered as one of the transformation equation. Okay, so that part is clear. So now how do you get back to the second transformation equation? You can see that again Pi, if you differentiate F1 with respect to Qi, you will be getting Pi, which will be again F1 is a function of small q, capital Q and time t. Okay, so what we do, we can now substitute Qi. We can substitute capital Q, so then it would be, on substituting, you'll get a function in terms of small q, which is already there, and small p. Okay, so instead of q we can write small p and time t. Okay, so now the new expression would be a function of small q, small p and time t. How? We have substituted for capital Q is already in terms of small q, small p and time t. So capital P will again be in terms of only small p, small q and t. Okay, so this is how these two equations are equivalent to the transformation equations. Okay, or in general we call these two equations as the transformation equation of the generating function f1. Okay, now here also what you do is k has to be in terms of capital Q, capital P and time t. So all the terms which involves capital in terms of small q and small p, here also small q is involved, so all those will be written in terms of capital Q and capital P, so that we get a new function which is dependent only on capital Q and capital P and time. Okay, so this is how the transformation equations can be obtained if you know the transformation equations of f. Okay, so thus we can conclude that the transformation equations can be derived from the know-how of the function, generating function, and hence it is called generating function, because knowing the function we can generate the transformation equation. Now let us see how do you obtain the generating function from a given transformation equation. That is also possible. Let us consider the transformation equations we know, that is Qi is a function of small q, small p and time t, and capital P is again a function of all set of variables. So what you do, we just have to invert the equation, first equation. So inverting, that is rearranging the equation, you will get P as a function of small q, capital Q and time t. Okay, and what you do, we'll substitute for P over here. So what you get, instead of P, now the dependence will be on small q, capital Q and time t, isn't it? That is what we are substituting. So Q dependence is already there, so we'll get, instead of P, now you have a dependence on capital Q and time t. Okay, so we get capital P as in terms of small q, capital Q and time t by just substituting for P from here. Okay, now we can see that both the given equations have been expressed in terms of small q, capital Q and time t. So which is the function which involves small q, capital Q and time t? Yes, you know it is the generating function must be f1. Okay, while f2, f3, f4 have a different dependency. So from this arrangement we can conclude that it will be contributing, or it would be generating a function f1. Okay, so now you can make use of, making an inference that it is a generating function must be f1, we can make use of the transformation equations of f1. That is also known. So you have to remember the transformation equations of each equation, each function. So here you can see we already know Pi is equal to dou f1 by dou q1, so that can be equated, and minus Pi is equal to dou f1 by dou qi, so here that could be equated. So now you have two set of equation. So those are partial derivatives. So now just by integrating these two equations you will get back the f1. So starting from a transformation equation, we can reach up to corresponding generating function. Okay. Now let us obtain other generating functions, that is f2, f3 and f4 from f1. Now you know we make use of legendary transformation to obtain f2, f3 and f4 from f1. Let us see how. So you know f1 is a function of small q, capital Q and time t, and f2 is a function of small q, capital P and time t. So what is the difference between these two? Yeah, one of the bases is different, only one, isn't it? Q has to be changed by capital P. Okay, so the technique used for changing one basis to another is what you call legendary transformation. So what we do is that the new function f2 can be obtained from the old function, that is f1, by just subtracting the old function with respect to the changing variable. Which is the changing variable? Q is getting changed. So we had to differentiate dou f1 with respect to the changing variable qi into multiplied with qi. Okay, very simple. Whatever be the basis that is being changed, we have to subtract the differential of f1 with respect to the changing variable into the changing variable as such. Okay, that is how you can obtain f2, and this method is called legendary transformation. So but you know what is dou f1 by, from the transformation equation of f1 we know what is dou f1 by dou qi. What is it? It is minus pi. So substituting here you will get it as plus, minus of minus become plus, so plus pi qi. Okay, now what you do is we'll find out f1 from here in terms of f2, that is equal to f2 minus pi qi. Okay, so now you know what is the condition for getting a canonical transformation. Pi qi dot minus h equals capital Pi capital Qi dot minus k plus df by dt. So we always substitute instead of f as f1. Okay, that is why we have written what is f1 rather than f2. That is a mistake every time it is seen to make by the students. That is, they would be substituting with respect to f2 itself. Okay, better to substitute with f1 itself so that we can get f2 from here, the transformation equations of f2 from here. Okay, let us see how it is. So taking equation as such, instead of f1 we can write it as, what is f1? f2 minus pi qi. Okay, so d by dt of f2 minus pi qi. Okay, so now we have to remember what we have mentioned. The total derivative would be written as partial derivative of f2 with respect to the first variable into the total derivative of that variable, dqi by dt, plus partial derivative of the function with respect to the second variable, that is pi, into dpi by dt. Then third one, partial derivative of f2 with respect to the time into dt by dt, which is 1. Okay, minus, here we have to apply the product rule. Pi qi is there, so it is pi qi dot minus qi pi dot. Okay, so here you can see pi qi dot can be cancelled out. So whenever you make a cancellation, you can put a tick mark over it. Do not cancel it by crossing it out, because it would give a clumsy look when you write in your examination. Okay, so never cancel by cutting it off, but instead you can make a tick mark over it, whatever be getting cancelled. Okay, so I have put a tick mark over here. So the remaining function you can see. Okay, we can also write qi dot. Instead of this I can write qi dot. Instead of this I can write capital Pi dot. Okay, so that is what I have written here. So finally I can cancel it out. So the remaining things are, we have terms involving Qi dot, capital Pi dot. Okay, here also small Qi dot. So the same comment is applicable here also, that is small q and capital P, which are the functions in F2, are independent of each other. So they must be separately vanishing terms. So using that concept, you can see that equating the coefficient of Qi dot. So Qi dot, the coefficient is Pi equals, where is the other Qi dot? Here. So the coefficient is dou F2 by dou Pi. So that is the first term we get, first equation that we get by equating the coefficient of Qi dot. Next we have Pi dot here. Okay, so the coefficient is dou F2 by dou Pi, and the next one is minus Qi Pi dot, which are both in the same side. So equating those, we will get Qi equals, capital Qi equals dou F2 by dou Pi. So the thing to be noticed is that both are positive terms, and F2 is already contains small q, so we need to find out Pi as transformation equation. It contains capital P already, so we need to obtain capital Qi as the transformation equation, and both are positive. So this is how we remind or keep in memory what is the transformation equations of F2. And finally, combining all the remaining terms, you can see h is or k is equal to h plus dou F2 by dou T. Those are the remaining terms in the condition. Okay, so these are the three equations, transformation equations of F2. Okay, now you can also obtain other generating function from F1, that is using the legendary transformation equation itself. So here you can see F3 is a function of small p, capital Q and time t. So what are the changing things? Yeah, small q is getting changed to p. So the basis which is getting changed is q. So what would be F3? F3 can be written as, by changing q by p, that is F3 is written as the old function, that is F1 minus the differential of F1 with respect to the changing variable. What is getting changed? Small qi into qi. Okay. Similarly, you can find out F4 also. Here it is F4. Sorry for that. So here you can see which are the bases which are changing. Yeah, both small q and capital Q are changed to small p and capital P. So it would have two terms involving showing the change. The one would be the old function minus dou F1 by dou Qi into Qi, minus the second change is dou F1 by dou capital Qi into Qi. Okay, so once you have written the legendary transformation, you can write down what is F1 in terms of F3. From rearranging this equation, here also you can write down what is F1 by rearranging the equation. So finally you can substitute in the conditions for canonical transformation as we have done with F2, and obtain the transformation equation. So hope you will find out the transformation equations of remaining generating function, and let's have a comparison of all the transformation equations. Okay, thank you. Make a try and take care.